Now we're going to take a look at the next couple of problems that are on the answer key. I believe that's problems 6, 7, and 8. Scroll down a little bit. Here's number 6. Number 6 is a pulley problem where there's a 2-kilogram block hanging from the right side and someone is pulling the rope here on the left side. I'm going to say that anything that pulls makes this thing go clockwise is positive. Anything that goes counterclockwise is negative. Force is acting on my 2-kilogram block. I've got tension going up and I've got gravity going down. For my block, I've got gravity as actually a positive one. You might say, wait, I thought that's down. But remember, I said anything that's going in the clockwise direction is positive. So if you follow my mouse, it's going clockwise, and that's anything that's moving down on this block. So gravity is actually a positive thing. Tension's going the other direction, so it's negative. Put them together, and you get 0. So my clockwise stuff equals my counterclockwise stuff. Force of gravity, I know, is mass times g, which is 9.8, and it's still going to equal tension. So my mass is 2, my g is 9.8 meters per second squared. That equals the tension. Plug into my calculator, and I get 19.6 newtons. The pull is on the rope, causing the tension. So the force of pull is the exact same as tension. You're pulling on a rope, so the tension is how hard you're pulling. So you pull 19.6 newtons. Going down to number 7, here's an 8-kilogram object that's being held up by 2 different ropes. They're going straight up in the air. And I've got gravity that pulls straight down. I don't have any forces that move at weird angles, so no right triangle, sine, cosine stuff to do. I just have my up arrow, one of the tensions, plus my other up arrow, another tension, minus my down arrow, which is force of gravity, equals 0. So my 2 up things, 2 tensions, equal my down stuff, which is force of gravity. Divide by 2 because I'm just trying to solve for what the tension is, not both of them at the same time. And I divide by 2, so I get tension equals force of gravity divided by 2. I know force of gravity is mass times g. So I can plug in what is mass, what is g? Mass is 8 kilograms. G is 9.8 meters per second squared. I still have 2 in my denominator. Plug in your calculator, and you find that each tension has to hold 39.2 newtons, or half the weight of the object. We'll finish up with number 8. For the 5-kilogram mass, which is hanging down here at the bottom, it doesn't know, this rope here, tension 1, it doesn't know if it's hanging from another mass or the ceiling. So we can treat this one like just an object hanging from the ceiling. So what arrows are acting on it? Tension 1 goes up, force of gravity pulls down. That's where my equation comes from. Up arrow minus down arrow equals 0. My up stuff equals my down stuff. Force of gravity is mg. I plug in 5 kilograms for m, g is 9.8 meters per second squared, and I get that the tension 1 is 49 newtons. For the 8-kilogram mass right here, tension 2 points upward. That's why it's positive in my equation. It also has weight on it, which is its own force of gravity. Its own weight points downward. That's why this is minus force of gravity 2. Usually people get hung up on this minus tension 1 thing. What is that? Well, this 5-kilogram block has a rope tied to the 8-kilogram block. So this 8-kilogram block is getting pulled down by the 5-kilogram one. How much is getting pulled down? It's getting pulled down by how much the 5 weighs, which is the same as tension 1. So tension 1, or the weight of the 5-kilogram block, is the same thing. So my up arrow minus my down arrow minus my down arrow equals 0. So my up stuff equals my down stuff. Force of gravity is mass, 8, times g, 9.8. And tension 1 we already solved for, which is 49 newtons. Plug all this into our calculator, and we get 127.4 newtons.